Today we're going to be learning about area of composite shapes, and it's a little recap of what you learned yesterday. Just to remind you, composite figures is the same thing as like a compound shape, meaning that you are taking two or more 2D shapes to combine to get an entire composite figure. And this is what will lead into the surface area of nets. Right here, we need to start by step one, naming our two shapes that we see. And I see a square and I see a triangle. The only reason I know this is a square and not a rectangle is it says 16
Please come to the front office.
by 16.
Please come to the front office.
So I see a square, I see a triangle. If you have highlighters, I highly recommend you highlighting each of your shapes that you see. So you have your square and you have your triangle. You always want to pay attention to, are the shapes overlapping in any way? Like, is the triangle inside of the square? Is the square inside of the triangle? If they're not overlapping, then that means you're combining all of this. For example, if you were covering your backyard in grass, this is all your grass area. If you had one little section that stuck out, you would also want grass here. But you would break it apart into a square and a triangle to try to figure out this weird shaped yard. So now I need to write my formulas. So after I break my shapes apart, I need to write what formulas that I need. A square is the same as a rectangle. So you have a choice. Your formula chart says A equals base times height, or you can choose to use length times width. Either one, they're the same exact thing. So I need to make sure before I move on, let's make sure we have a base and a height, or a length and a width of our square. I have the bottom. If the top is 16, then that means the bottom also should be 16. And that means I also have a height of 16 since it's all equal. So I know I have the base, I have the height right there. Okay, triangle. I need my triangle formula. A equals half of my base times my height. So let's check out the triangle to see if you'll be able to plug in your numbers here. I have a base of 8. Yep, I have my base. There it is. Here's my base here, and here was my height. Now I need to check out my triangle's height, because it should always go perpendicular to the base. So if I look at this, I know that it's 8 from here to here, but I don't know from here to here. I always want to check across from right here to check this number, because this number tells me the distance between the whole side of the square. So if I know the whole side of the square is 16 and 8 is this top part, then 16 minus the 8 leaves me with 8 as my missing height. So now I have a height of 8, I have a base of 8, and I can plug them in. In a few minutes, you're going to be plugging the numbers in right here and calculating the total area. Total, remember, for all of the shapes that are not overlapping means that you find the sum of the two shapes. If there is overlapping, you're finding the difference, and we'll get to those if we come across that. So on this shape, I see a rectangle. I see a rectangle, and I see a triangle. And you can use your two colors again. I'm not going to write the formulas down because I think you can copy down the same formulas that you did on the first problem. But I'm going to make sure that you do have a height and a base for each one of these. So the rectangle, I know my formula is going to be these, the same formula. A rectangle on here, if I look, this one looks kind of crazy going across the top. So let me look at the bottom. I know the whole entire base is 18. So I need that, or you could call it the length if you want to say the length of the rectangle is 18. My height or my width of my rectangle is 9. So my rectangle, I'm set. I got my length and my width, or my base and my height. I should be able to write my formula and plug those in. The tricky part is the triangle. I know I need a base and a height for my triangle. If I look at this, I only know 4, and that is my height. So now I need to look at across the bottom, and I don't know what the bottom of it is. So I have to use my rectangle links to kind of assist me on figuring out this missing part. I know it's 18 all the way across here. So from here to here, it's also 18 long, all the way across there. It's 18. So if this is 6 plus this side is 6, 6 plus 6 makes 12. So that means whatever it goes right here has to equal this whole 18. So 18, take away my 12, leaves 6 right here for my base of my triangle. So I have a height of my triangle, a base of my triangle, and now you can calculate that. Now we're going to move on to a little more challenging of a shape that has, these two look very similar to one another. So we're going to do this one together. It has a rectangle. I see a rectangle, and then I see something that looks like a circle, except it's only like the side of the circle or the top part of a circle, which is a semicircle or semicircle, half of a circle. So I'm going to write which two I see. I see a rectangle, and you should be used to rectangles by now. And then I see a semicircle, which is half of a circle. So let's write our two formulas down. Let's start with rectangle. I would do length times width or base times height, either one, whichever one you like to do. So if I was going to plug these numbers in on here, I would say my base times my height or my length times my width. I have a 6 as my base, 4 is my height, or 6 can be my length, 4 can be my width. So I would have A equals 6 times 4, and you can calculate that. On the semicircle though, my formula is a little different. It's pi radius squared, all divided by 2, because I need to take half of my pi radius squared. It's half of a circle. So on here, I'm going to use pi as 3 to make my life a lot easier. 3 is about pi. My radius though, I don't have any numbers on here, but I can use my rectangle to help me. The width or height of the rectangle is 4, so that means all the way across here is also 4. But as a circle, I know a circle that goes all the way across, the distance across is my diameter. So that means in my formula, I need a radius. I don't need a diameter, I need a radius. So if I cut this right down the middle, instead of it being 4 all the way across, this would actually be 2. So I would say pi times 2 squared, all divided by 2. So make sure you follow your PEMDAS order of operation rules. You want to do your exponents, 2 times 2, and then times your pi, all divided by 2. When you get your two areas, since neither shape is overlapping each other, you're always going to add them. You're going to take that answer plus that answer to get your total area, meters squared. Okay, and you're going to do this one the same exact way. Let's try one that is overlapping though on the back side. So flip your page. If you notice this top one, this one is not overlapping. We're going to get to the overlapping, but on this top one, I will help you name your shapes that you see. I see right now a rectangle, so every shape on this whole notes, we have seen our rectangle. So by now, you should be used to the rectangle. And our formula for a rectangle is either base times height or length times width. So the base and the height, are they provided? Yep, 10 is across the whole bottom, or the length. My height would be 7, or my width, whichever one you want to call it. So I have my 10 and my 7, so I could multiply that over here. However, now this is something new. We have something that makes this right angle right here. It does have a little right angle in here. That means it's not half of a circle, because half of a circle would be if I continued it all the way over here, then it would look like half of a circle. This is a quarter of a circle, meaning it is split 4 ways. So this is a quarter circle. So when I plug in my formula, I'm going to write A equals, and I'm going to write the formula for a circle, pi radius squared. But I need to remember that I don't have a whole circle. I only have a quarter, a fourth of the circle. So I divide by 4. So if I was going to plug these numbers in, let's see if we can figure out what the radius is. I need my pi 3. The radius is halfway to the center of the circle. This would be the center of the circle because this would be the other side of it. So I need to think about what this length is. If the whole rectangle is 10, and I know this little part up here is 5, then that means this other little part is 5. And that would be my radius. So 5 squared times your pi, which is 3. You'll do 5 squared, which is 5 times 5, times your pi, all divided by 4. All divided 4 ways. And that will probably be a decimal answer, something close to it. But once you get the area of your rectangle, plus once you get your quarter circle, you have to add your 2 areas up to get your total shapes area. All right, the last one we're going to do, though, is a little different. This is actually shaded in on this shape. We have this is shaded. I know it's a little gray. It's very light colored gray. But then you have a big rectangle. So as you notice, my purple shape is inside of this rectangle. That means they are overlapping. They overlap. Overlap means we are not combining the 2 areas because they're already combined. We don't want this area. We want to take that area off. This one we want to take off of the rectangle. It's like if you wanted to paint this whole wall, or you wanted to floor your floor in your kitchen, but these were cabinets, and you want to take all of that but not that. So we're going to start with the rectangle. The bigger shape is what you always want to start with, the whole shape, the big shape, which is the rectangle. And we want to take off our triangle. So this is going to be a subtraction problem, where all the other ones, they weren't overlapping. We added the 2 together. These are going to be subtracting. So we still do area equals base times height, or length times width. And then you move on to your triangle, same formula as we used on the front, half base times height. Let's make sure we have our length and width and base times height. So let's look length and width. I have the length of the whole rectangle, or the base of the rectangle, is 10. If the top is 10, that means the whole bottom is 10. So my whole base is 10. My height would be 8. So I have my height, I have my base. So you can find the area of the whole rectangle right over here. Now the triangle, I have 4 as my base, but then I have a height that is connected to the 3. I know the whole rectangle is 8 from top to bottom. So if this little bitty part is 3, then I need to take 8 and take off my 3, and I get 5, because 5 plus 3 makes the whole side of 8. So now you have a base and you have a height of your triangle. Once you get both your areas right here, you have to subtract the 2 areas. You have to subtract them because they are overlapping. Once you complete all of the problems on the front, the 4 on the front, and then these 2, then you'll move on to the star practice problems. There are a couple of problems that ask you to measure the dimensions, meaning they don't give you any numbers. And on your formula chart in class, or your own copy, you have rulers on the side. You have one that says centimeters right here, and on the other side of your formula chart, you have one that says inches. So you are going to be measuring this one to the nearest centimeter. So you need to make sure you use that side. And it tells you what to measure. Measure the dimensions. You know you're going to need your base and height of your triangle. And you could probably measure to the nearest whole centimeter, because it says you can, so the nearest whole number. And then measure your height. Just